Hello everyone, I am santhosh.dk, Assistant Professor, Department of Computer Science and Engineering, Canara Engineering College, Mangaluru. I am going to discuss data structures with C laboratory course with subject code 18CSL38. In this course, we will be conducting 12 experiments, and any study material regarding this course is available on my website. Along with that, you'll also get a study material on C language and varieties of other subjects which I handle. Also, you'll get the opportunity to use online compiler in my website. You can run the code on the go.
Hi all, we will discuss 12th experiment in this video. The 12th experiment problem statement goes like this. Given a file of n employee records with a set of k of keys, which is of 4 digit, which uniquely determine the records in the file f. Assume that file f is maintained in memory by a hash table of m memory locations. We are having a limited m memory locations for a given file with L as the set of memory addresses. For those m memory locations, we are having L memory addresses which is of 2 digit. We have to have a keys of 4 digit. For that we should get a 2 digit address, 2 digit of locations in the hash table. Let the key in K and addresses in L are integer. It means K is a set, L is a set, which are having a K is having a set of keys, L is having a set of addresses. Both are integer numbers. There is no fractions over here. Design and develop a program in C that uses hash function. The hash function is given here. How to build a hash function, we need not to worry. They have only given the standard hash function. Hash function, it should take a key and it should generate a 2-digit address. So we know what is K is. K is a set of keys and L is set of addresses. We have to read a key and we have to generate an address. As the function goes like this, h of k, the hash function of k will be k mod m. We will be taking a m. So on we are taking a key on which we are applying a mod m and we will be getting a 2-digit hash key, 2-digit memory address we are going to get, and implement hashing technique to map a given key k to the address space L. We have to implement our technique to map this key k to address space L. Resolve the collision. If there exists any collision, if there is a overlapping, if there exists there is a situation of overlapping, that we are going to call it as a collision. That situation we have to resolve using a linear probing technique. Let's see the definition of hash table. The hash table is a data structure that represents the data in the form of key value pair. Each key is mapped to a value in the hash table. The keys are used for indexing the values or data. Here we are going to rename key as address and value as key according to the question. So what is the main role of hash table is, it is going to create an index where the indexing is the easy way to identify the values specified in the memory location. So when it comes to hash table, there are two components of hash table. One is hash function, which is going to generate an address for a given key, and another one is a hash table itself, which we are going to represent with the help of arrays. Whenever we are performing a entry in the hash table, there is a chances of collision. The collision is a situation where we are going to get a similar address after applying a hash function to a given key, and there is a chances of overlapping. To avoid this overlapping, to avoid this collision, we are having many techniques. One is linear probing. If a pair is hashed to a slot which is already occupied, it means collision occurred. It searches linearly for the next free slot in the table. If it is going on with the searching for a next available free location, if there is a free location, it's going to allocate that respective location for the key. The another technique is chaining. The hash table will be an array of linked lists. All keys are mapping to the same index, will be stored as linked list nodes and at the index and at that index. So what we are going to do over here in the chaining is we are going to go with the concept of linked list. In the linear probing, we will be going with the concept of arrays. In chaining, we will go with the concept of linked list. This is not there according to the experiment statement. We are going with the linear probing, but still we'll see the another technique also, resizing the hash table. The size of the hash table can be increased in order to spread the hash entries further apart. If there is a more requirement for entries, what we can do is we can resize the hash table, which should be a dynamic. So these two are little complex techniques, and linear probe is the easier technique which is there for the experiment according to the question. Let's see the working of hash table with a linear probe. Here the question was designed for a 2-digit hash key, 2-digit address, but we have taken only 1-digit address, because if we are going for a 2-digit address, we need 100 locations for a discussion. That is quite difficult to fit in a slide. That's why I'm discussing a single-digit address. If you are interested to go for a 2-digit address, rather than 10 over here in the hash function, make it as 100. And whenever we are entering a key, the key consider over here, it is 5643, which will be given as an input to the hash function. The hash function generates at present 1-digit address. So if you take a modulus of a given number with a 10, it is going to give you the last digit, that is 3. And let's check for the 3 at the address in the given hash table, whether it is already occupied or not. It is not occupied, so it means there is no collision. Then we are free to enter that 5643 on the location 3. Similarly, let's try for the another value, another key. So here another key is 4345, and of course the address will be 5, and there is no collision, so we can enter it. Next, let's check for a collision. The key is 6423, the address is 3, where 3 location is already occupied by the 5643, which was our first entry. So how to avoid this? We'll apply a linear probe algorithm, which is responsible for finding the next available free location. Which is the next available free location over here? The 4th address is the next available free location. So where we are going to enter 6423. And we will try to fill all the 10 entries of the hash table now. First, we have tried with the 5643. The address was 3. Collision was not there. And next 4345, and the address was 5. Collision was not there. Yes. And 6423, address was 3, but it is already acquired by 5643. There is a collision. To avoid the collision using linear probe, it's going to allocate at the location 4. And next is 1234. The address is 4. There is a collision, which is the 4th location is occupied by 6423. So we have to find the next free location, which is 6, where we are going to enter. Next 8756. The address is 6, but that is occupied by the 1234. There is a collision, so we have to find the next free location by using the linear probe. Then 9000. So if I take a key 9000, the address is 0, which is free, which is not occupied. So what we are going to do is we are going to write the value over there, and there is no collision. 3872, the key is 2, again the location is free, we can use that location. 7777, so the address is 7. Yes, there is a collision which is occupied by the previous value 8756. So we have to apply linear probe to find the next free location. Next is 8899. So ninth address location is free, so there is no collision, we can update over there. Next is 3456. 3456, sixth location is filled, so we have to find the next available free location, that is at the 1, and we are going to update this. Let's try to insert more, like 4545. The hash table is already filled. As I said, we are taking a hash table for 10 element over here. So if I try to insert the 4545, there will be a warning message, hash table is full. This is how the hash table will be indexed with the help of linear probe for a given key values. Let's see the implementation part. Here you can see all the values whatever I have taken, the same way it's going to work, which is having more loops and conditions. First, we'll be asking for a 4-digit key. So you have to give 4-digit key. If you give more than that, also this scanf is going to read only first 4 digits. Then the hash function. Hash function job is to generate an address by taking a key by applying the modulus operation. And the question was for 2-digit address, but we explained for 1-digit address. For 2-digit address, here you have to change it this 10 to 100. Then check for the respective location. If A of address is -1, initially I am setting the how to represent the hash table is empty. Initially set the complete hash table to -1 value. So the -1 represents it is not having a valid values, and positive values represents it is having a valid value. So I have set it to -1. It means it is not having a value. So initially there is no value in complete hash table. It will allow us to add a key whatever we have entered for the respective address. Otherwise, if it is not having, if it is already occupied, so we are going to tell the collision is detected, and let's see how to avoid the collision. First, let me count how many entries are there in the hash table. Already how many locations we have already used. That I am going to count over here. The reason to count over here is to check whether the hash table is full or not. If the hash table is full, then need not to apply the linear probe technique. If a hash table is empty, then only we have to apply the linear probe technique. If hash table is full, the max is 10. So if hash table is full, if count is matching with the 10, then I am going to display a warning message, hash table is full, and I am also displaying the complete hash table content. Otherwise, if hash table is not full, then what we are going to do is we are going to display a message, collision avoided successfully using linear probe. Let me avoid this. Just I have given a message. Let me check how to avoid it. So I'll start from iterating from the key +1, whatever the it should be address, whatever the address we have taken. I'll change it to address. Whatever the address we have generated, from that to +1, what we did in the previous discussion, we had a third location was occupied. We started with the fourth location. So that is why from +1 location, we start till the end of it. So if there is any empty locations, how to represent the empty location? -1 is going to represent the empty location where I am going to make an entry for the respective key. And I am going to set flag is equal to 1. It means I have already used that location. And if flag is equal to 1 means what? I have already stored that value, a key, somewhere in the next part of the hash table. If I am unable to find the empty location in the next part, which has happened in the last value, where 6 was the key, sorry, 6 was the address where the 6 to 9 all are filled. So what I have to do is I have to opt for a location 1. So if I have to opt for a location 1, then flag is going to help me because I did not updated that value. What I will do is I will start with again starting from the beginning. So until when? Until key, because from key onwards I have searched, and if I have not updated that, sorry, this is again address. This is address. I will start with that 0 to till that address, and if the flag is set, and if that flag is set, what I will do is I will try to find a empty location, and I'm going to complete that entering the value. So, and once after that, this is for one value. If you want to continue, if you want to add up more values, we'll be asking for, do you wish to continue? If we are going to say yes, then we are going to ask you a new value. A same procedure is continued until you are going to stop this. And the display function is very simple, where we are going to display the address and the keys. And what we are going to do over here is we are going to take up a simple for loop to display a single dimensional array. This hash table is a single dimensional array. We'll take up a single for loop to display this, where it's going to display address and key, both the content. The main program goes like this, where we are having a first for loop. I told you initially I'm going to assuming that there is a hash table which is empty. So that I'm going to set by storing -1 in the all the locations of the hash table. Then after, we are going to give you a choice for insertion, display and exit. Once after, you are going to choose appropriate choices. If it is choice 1, it's going to apply create a hash table with a linear probe, or else if you are willing to display the table, it's going to display the table hash table with display function. And if you are coming out, it's going to be the end of the program. And these are all the references I made to explain this. And let's see the demonstration. Let's see the demonstration of 12th program, where we are having a linear function, linear probe function, which is responsible for creating a hash table and entering the values to the hash table. If there is any collision, it will try to avoid the collision until the hash table is full by searching for a next available free location linearly. And if there is any, if the hash table is full, then it's going to display the hash table full message, and it will display the content of the hash table. So here we have already discussed the code. First, it will read the 4-digit key, and it will generate a address. And as I said, it is going to be a single digit address, but if it is a 2-digit address, you should add 0 over here. And if the entry is not there in the hash table, that is how we are going to get it by -1. -1 indicates empty entry in the hash table. So easily we can occupy that location for the respective key. Otherwise, collision is detected, message will be displayed. Then we will count the from 0 to n, like 1 to 0 to 9, all the locations which are all free. So if the count is not free, it means it is having all the locations are not free. If all the locations are used, then what we are going to display is hash table is full, and we are going to display the hash table content. Otherwise, if there is an empty location, then there is a chances of avoiding the collision, and we can allocate a location for the new key what we are trying to allocate. So the loop starts from address +1, that is the next location, where exact from that to till max, and we are searching for a empty location. If there is an empty location, we will update that value. If not, we will start from the initial to address. From the 0 to address, we will search, and if we get there from initial to address, we will try to fit that key in the respective location. And display function is a single dimensional array display function. Next, we are having a main where we are asking for the choices. Before that, in this for loop, we will try to set the complete hash table to empty by specifying -1. -1 means here empty entries. Next, we will see the output for the same values what I have discussed in the presentation. Yep. The first choice I'll take insertion into hash table, where it's going to call a linear probe function. It's asking for a 4-digit key. I'll take the same values 5643. I'm starting with the initial version, so there should not be a collision. Yes, there is no collision, that's why it is asking, do you wish to continue? I'll insert all the 10 values. Yes, I wish to continue. Next, 4345, which is again that location is free, there is no collision. And next, 6423, and 6423 collision is detected because already 5643 is also having same address, and 6423 both are having address 3. Collision is detected, but collision is avoided successfully because it is stored in the next location. Next, do you wish to continue? Yes, and I will take up the next value 1234. Again collision is detected because 6423 occupied the 4th location, and again we have avoided the collision by finding the next free location. Again, let's continue. 8756 is the next number. Again collision is detected because that is the 6th location is occupied by the 1234. Next, again we will continue. Next, again we will continue with the next value 9000, where the key will be 0, and where the address will be 0, which is free. So I will continue. Next, 3872. Yes, again this is free because the key is address is 2, which is not acquired. Next, let me continue. 7777, which should be collision. Yes, it is a collision, and it is also avoided by occupying the next location 8. Next, let me continue with the next value 8899, which is free. Yes, it is free, no collision detected. Next, let me continue with the next value 3456. Is 6th location is already acquired, but we had a free location at the location number 1, so collision is detected and it is avoided. Let me continue. I have entered all 10 values now. If I continue now, if I give a key value now, it should give me a hash table full, and it should display a complete hash table. Yes, it's giving me a hash table full, and it is displaying the complete hash table with the address and the keys. And if I give choice number 2, again it's displaying the same hash table. This is how hash table is created, and if there is any collision, which is avoided using the linear probe function. And you can try out for the 2-digit address also, where you have to fill 100 locations to show the hash table full error message. That is why I have taken a single digit address. Thank you.